And we're back with another PicoCTF challenge. Static ain't always noise. And when we look at the description, can you look at the data in this binary? We'll download that guy. This bash script might help you. Grab him as well. And we will keep the file. And we'll open up, let's see, open up our downloads. And I want to view this all inside of VS Code. So we have our static, which can't be displayed, but let's do some quick checks on it. So we'll get our terminal and we'll just ask, what kind of file is static? Well, it's an executable, 64-bit, so we can run it if we give it run permission. So let's go ahead and do that and see what it says. Oh, hi, wait, what? A flag, yes, it's around here somewhere. All right. We're also given this shell script, and let's take a quick look at what it's doing before we run it. It's attempting disassembly. It tries that. And then it runs strings. So the echoes are just print outputs of what it's doing. It's running strings and it's dumping it to a file. So let's go ahead and let's make that executable so we can run it. I'm just clearing to make things a little cleaner. And let's see what it does. Attempting disassembly of obdump a.out, no such file. Okay, so a.out is typically the file you get when you just do compilation and you don't tell it what to name the compile target. And we'll talk about compilation in just a minute. So what this tells me is I should be calling it with a program name. Otherwise it's going to use this default a.out that we're not interested in. So let's try it again, this time giving it the name static. Attempting disassembly of static, successful, available at this file that just came out. Ripping strings from the binary, and those are written to another file. So let's look first at lt disassemble. And what we're looking at here is, so machine code is what we're seeing on the left. We're seeing where the machine code is located, so what address, what the machine code is. So the raw binary displayed here is hexadecimal. And then we're seeing what it's interpreted as in terms of instructions. So it's very difficult for most people to read 31 ED. But if you're told it's an XOR taking this register and this register, yeah, it's still hard to read, but it's a little more manageable. We'll come back here and we'll talk about this for the time being, but I'm just quickly scrolling through and I don't see the flag. So let's see what strings has in it. And we see that message that we were originally given. Oh, hi, wait, yes, there's a flag somewhere. And then we also see PicoCTF, and it looks like disassemble something. Something to do with disassemble is what they're doing in that lead speak in there. So let's go and try that, and then we'll come back and we'll talk about what was going on. We submit it, and it accepts it. Awesome. So first thing is, what does strings do? And to find out, I just Google it. And you can find there's a man page, and for a given file, it prints the printable character sequences that are at least 4 characters long and are followed by an unprintable character. By default, it prints the strings from the initialized and loaded sections. Okay, all right, we don't need to know any of the additional details. So what it's doing is it's looking at an ASCII table, and it's looking, so you can have many unprintable characters, but there's this much smaller group of printable characters. And so for example, let's see, what's something that's unprintable? I think these are all printable, but once you go beyond this, they become unprintable. So if you have, say, hex 6b, 69, wherever t is, 74, 65, and then, do we need one more? Yeah, let's say 73. And then an unprintable character, it'll see that and it'll decode it as kites because it's more than 4 characters and it ends then in an unprintable character. So that's what's happening with the strings that we saw that gave us this output. So this is all the printable stuff that it could find in here. And there's a lot of stuff that doesn't make a ton of sense right now, but that's okay. Now let's focus on the disassembly and what's going on with obdump. So we have this static file. We're going to open it and we're going to look at a hex editor. And we can see here all the hex. And you can see how it's being decoded as ASCII on the far right. So some of this stuff makes sense and it can be decoded. Most of it cannot. So here we're probably seeing strings that we would also see if we were to open up the strings file again. This is not all supposed to be read as ASCII. Some of it is actual machine code. And when we look at the disassembly, what we're getting is we're getting it interpreted not as ASCII, but instead as machine code. So for example, let's go to the very top. So it's saying at line 530, I see 31 ED, and that's actually an XOR. So if we look here in static at line 530, we see 31 ED. Cool. I wouldn't know what that is without the help of the disassembler, taking it one level up from machine code into assembly. And then we see 49 89 and a D1. Do we see that here? We do. So it's helping us to interpret. And I want to show you the other way things could be going. So I want to write the world's simplest hello world.c. And I'm going to cheat, and I'm going to grab this and copy it directly from the site. And we're going to compile it, and we're going to see what the output looks like. So in order to compile, we're going to do GCC, which is the GNU Common Compiler, I think. We're going to give it the name. Actually, let's not give it a name yet. We'll just say we want to compile hello world. Okay, it didn't complain. And you'll notice it called it a.out. That was that default name that we were talking about earlier. So if we were to chmod and make that executable, we get our message, printf hello world. Cool, all right. If we wanted something a little nicer where it's not a.out, we could have given it an output flag. So let's call it say hi. And there we can see there's a say hi. Now I'd like to do the obj dump. I don't know why I can't say that. -D disassembles everything that it can. And then we'll use say hi, and we'll take a look at what that looks like. Oh, say hi, not hi say. And what we can see again is we're getting assembly out of what was originally machine code. So I'm going to open this again in a hex editor just to see. And this is a whole lot more readable. So here's what's cool about this and why this is interesting. No matter what a program is doing on your system, you can always look at the basic instructions. And yeah, it might be convoluted and it might be long, and you might prefer to have the source code, which you saw was very short relative to all the output that we're getting out of obj dump. Boy, I'll say that right once, maybe. So yeah, it's much easier to understand this conceptually. But if we're given something and we don't know what it's doing, we can always look at the assembly and we can figure it out. Or we can run strings on it and see what's available and what it seems to be doing. Anyway, hopefully that was helpful. Please like and subscribe. Bye.